in the previous video we saw two methods of how to find the integration bounded by a curve in just a quadrant or just a part of that curve. One was visually seeing what if we're at pi angles or 2 pi angles, etc. So finding which theta visually, but sometimes that is a little bit difficult. So we saw another way to do that is finding the y and x intersect, or when r is equal to 0, etc. This is because sometimes it is easier to do it that way than finding the theta angle, or sometimes could be impossible or almost. So now that we have already seen the two methods, let's continue. The other example is r equals to theta sine theta that corresponds to this graph. That is, we want all the area that is bound by this curve. Now, first note that this 2 theta sine theta, the cosine, well, the x is always positive, because here x is equal to 2 theta sine theta cosine theta, and y is equal to 2 theta sine theta times sine theta. Sorry, I meant that y is always positive. Here you have the graph, and the graph is always positive. That is because here you can see that y is 2 theta sine square theta. So it doesn't matter what the sign of theta is, because sometimes sine of theta is a negative number, but because we're squaring it, we have here that from 0 to pi are the same than from pi to pi, because always the y coordinate is going to be positive. Alright, now how do we find this? Here, let's be careful and not confuse this one with the integration of. We know that it's going to be 1/2 of the limit. Now, here is not the limit from 0 to pi over 2, because here we are doing from 0 to pi. This is just pi. From 0 to pi of 4 theta square sine square of theta delta theta. Now, if you're not comfortable with this just visually, let's do it with the intersects, or with r equals 0. So here we are going from one 0 to another 0. That is from r equals 0 to another r equals 0. So we can set this equal to 0. So we have 0 is equal to 2 theta sine theta. Either 2 theta equals 0, in which case theta will be equal to 0, or sine theta is equal to 0, in which case theta will be 0, pi, 2 pi, etc. So we're going from the first 0 to the second 0, and that is from 0 to pi. From 0 to pi. That makes you comfortable. Or the other way around is, let's do it with the x-axis. We are going from the first x-axis intersection to the second x-axis intersection. So that is when y is equal to 0. Y equals 0, so this is equal to 0. 2 theta sine theta times sine theta. Let me put it like this because it's easier. Here we already know that the values of theta are this, and for sine theta also this, because here, remember we said 2 theta equals 0, or sine theta equals 0. So anyway, we have this, and again, so we go from 0 to pi. We are going from the first x-intersect to the second x-intersect. That is, when y is equal to 0, we are at 0 and at pi. Also at 2 pi, but first at pi. So we go from the first to second 0. And also for the y-intersect. So x is equal to 0. 0 is equal to 2 theta sine theta times cosine theta. Either we have these values of theta, or when cosine theta is equal to 0, this would be pi over 2, 3/2 pi, etc. So the first y-intersect is at theta equals 0. The second y-intersect is at pi over 2. The third one is at pi. The fourth one is at 3/2 pi. Look, here we have the y-intersect is first at 0. 0, 0, because it's when theta is equal to 0, and when theta is equal to 0, we already saw that the x-intercept is also 0. The second, here we have a second y-intercept at pi over 2, and the third intersect is again at 0. So you can try to find the bounds of integration by finding the first two 0, the first are equal to 0, and the first two are equal to 0, or finding the first and second x-intersect, or finding the first and third y-intersect. That is if you are not comfortable with the visual graph, because sometimes in this case I think that was a little bit confusing. Now let's do this one. This would be the integration. Well, we want the area that is bound by r equals 2 plus theta, that is bound just in the third quadrant. So it would be 1/2 of the integration from pi to 3/2 pi of r squared, that is 2 plus theta all this square delta theta. You can say that we go from the second x-intersect to the second y-intersect. Let's do another. This one. This looks a little bit difficult because I don't know, it looks a little bit difficult to find which bounds of theta we are integrating with. There is a way of doing it. We are going from one 0 to another 0, r equals 0 to another r equals 0. Remember, this is x, this is y. So from one 0 to another 0. So the way of do this is equate this to 0, as we do it in the previous video and in the previous example. So 0 equals 2 minus 4 sine theta. So minus 2 equals minus 4 sine theta. Divide everything by 2 and switch sign. We have 1 equals to 2 sine theta, or sine theta is equal to 1/2. This is either at pi over 6, so 30 degrees, but also at 30 degrees at 120 degrees. That would be 4 over 6 of pi, and etc. We can continue. But the important issue here is we already found the two first values of theta in which r is equal to 0. So we go from, the integration goes from pi equals 6, from pi over 6 to 4 over 6 pi, and this is 1/2 of the integrand of 2 minus 4 sine theta square delta theta. Alright, now let's do the other one. This again looks that we want all the area bounded by the curve. Here let's be careful. We want again the bounds are again from one 0 to another 0. We go from, let's say, from this 0 and we come back again to this 0. So 0 is equal to 2 minus 2 sine theta, minus 2 is equal to minus 2 sine theta. Sine theta is equal to just 1, sine theta is equal to 1, or theta is equal to pi over 2, 3/2 pi, etc. So here we have the integration, or 1/2 of the integration from pi over 2 to 3/2 of pi of 2 minus 2 sine theta, all this square delta theta. Here again was very useful to do it. We go from one 0 to another 0 of r instead of finding the theta angles. Alright, let's continue. this graph now corresponds to theta plus sine theta. So we want the area that is bounded by the curve in the first and second quadrant. So if we do it visually, we have 1/2 of the integral from 0 to pi of theta plus sine of 2 theta all this square delta theta. That's it. Or the other way of doing that is, yes, we want the area that is in the first and second quadrant, but also you can say the area that is or that goes from r equals 0, because here we have r equals to 0, to the x-intercept. But remember that when r is equal to 0, that's a y and x-intercept. So we're going from the first x-intercept to the second x-intercept. Or you say from the first y-intercept to the second x-intercept. So if you want, let's find r equals 0. So 0 is equal to theta plus sine of 2 theta. This would be obviously when theta is equal to 0. So that's our first bound of integration, when r is equal to 0. And the other bound of integration is when when y is equal to 0. And remember that we want the second x-intercept. So y is equal to 0, and remember that y is sine of theta times r. R is theta plus sine of 2 theta. So either sine of theta is equal to 0, in which case we have theta equals to 0, pi, 2 pi, etc. Or this is equal to 0, that we already saw that is 0. So the second x-intercept is at pi. That's our second bound of integration. Or the other way around was just to find the first bound of integration. Here that we saw r equals 0, or the vertical intersect. Now let's do we saw the x-intercept from 0 to pi. Now let's just find this 0 also as x equals 0, in order to see that it's the same, but we don't need to do that, but let's do it quickly. So x equals 0, this is equal to cosine of theta times theta plus sine of 2 theta. This we know that is 0. That is the theta equals 0 if all this is 0, or if cosine of theta is equal to 0, theta would be pi over 2, and pi over 2, 3/2 pi, etc. We want the first y-intercept, that is 0 is less than pi over 2, so it would be at 0.